1. Hook. Imagine your app goes down during peak hours. Customers are frustrated, and revenue is slipping away. 2. The real problem in the cloud: failures are inevitable. Without proper design, you risk losing customers and damaging your brand. So, how do you build a resilient architecture? 3. The simple explanation: building for failure means you prepare your systems to handle unexpected issues. Instead of waiting for a problem to arise, proactively design your architecture to minimize the impact of failures. This includes utilizing redundancy, failure detection, and automated recovery processes. It's about being smart with your resources, so when things go wrong, you can bounce back quickly. 4. Real-world example: let's look at a startup called FoodieApp. They launched a meal delivery service that quickly gained traction. On a Friday night, they experienced a spike in orders, up to 10,000 requests per minute. Their initial setup relied on a single EC2 instance. As the traffic surged, the server crashed. Customers were left hanging, and the company lost over $50,000 in potential revenue that night alone. After that incident, FoodieApp revamped their architecture. They distributed their load across multiple EC2 instances in different availability zones. They implemented an auto-scaling group to manage traffic spikes, ensuring their service could handle 15,000 requests per minute without breaking a sweat. They even used AWS RDS with multi-IaaS deployments to keep their database resilient. The outcome? Zero downtime during their next busy weekend. 5. What to do instead? Let's break down how to design your AWS architecture for failure. Step 1. Identify critical components. List the components that are essential for your application. This includes your web servers, databases, and APIs. Step 2. Use multi-IaaS deployments for databases. Choose multi-IaaS deployments. This means your database is replicated across different availability zones. If one zone fails, your app stays up. Step 3. Implement load balancers. Use elastic load balancing to distribute incoming traffic across multiple EC2 instances. This will help manage sudden spikes in traffic without crashing. Step 4. Set up auto-scaling. Create auto-scaling groups for your EC2 instances. Set minimum and maximum instance counts based on expected traffic. For instance, if you anticipate 5,000 requests/minute, set a minimum of 3 instances and a maximum of 10. This allows your system to scale automatically based on demand. Step 5. Monitor and alert. Use Amazon CloudWatch to monitor performance metrics like CPU utilization and request counts. Set thresholds to trigger alerts. For example, if CPU usage exceeds 70% for more than 5 minutes, you should be notified. Step 6. Test your failures regularly. Conduct chaos engineering tests. Tools like AWS Fault Injection Simulator can help simulate failures. Monitor how your system copes and refine your setup based on the results. 6. Common mistakes. Here are 5 common mistakes to avoid when designing for failures, along with how to prevent them. Mistake 1. Ignoring single points of failure. Don't rely on a single instance for critical services. Solution. Always have backups in different availability zones. Mistake 2. Not planning for traffic spikes. Underestimating demand can lead to crashes. Solution. Use auto-scaling based on historical data to predict future traffic. Mistake 3. Overlooking data backup. Failing to backup data can lead to catastrophic loss. Solution. Implement automated backups and use versioning in S3. Mistake 4. Lack of monitoring. Without monitoring, you won't know when things go wrong. Solution. Set up CloudWatch alarms to notify you of issues in real time. Mistake 5. Not testing recovery plans. Having a plan is useless if you don't test it. Solution. Conduct regular failover drills to ensure your team knows the process. 7. Quick checklist. Identify critical components. Use multi-IaaS for databases. Implement elastic load balancers. Set up auto-scaling groups. Monitor with CloudWatch and set alerts. Conduct chaos testing regularly. 8. Summary plus CTA. Designing your AWS architecture for failure is crucial for any startup. It's not just about preventing downtime, it's about ensuring a seamless customer experience even when issues arise. Remember to identify your critical components, utilize redundancy, and regularly test your system. If you found this guide helpful, comment below with your thoughts and subscribe for more practical tech insights. Let's build resilient systems together. Bonus practical tip: if you're unsure what to pick, start with the simplest option that ships today. Then measure for 7 days, latency, errors, deploy time, and cost. Only upgrade when metrics force the decision, not fear. Quick recap: keep it simple, avoid over-engineering, and build the smallest thing that works. If you want a real demo or checklist, comment demo. Subscribe for practical AWS, DevOps, Docker, and Kubernetes lessons.